Tech Nuggets, Firewalls with pfSense. We're going to talk about firewalls and what is a firewall. We're going to talk a little about pfSense firewalls, which is the piece of software that I'm going to demo in our practical demonstration, as it's a good implementation of a relatively easy to use and powerful firewall. We're going to talk a little about the network setup that we're going to lay out in the demo so that we can kind of go through what it means and what it does, and then we'll move on to the demo itself. Firewalls. A firewall in many cases is a fancy router to nowhere. And that being said, that means when we find packets we don't like, we throw them away. They don't go anywhere. They go in the bit bucket in the sky and they're gone. And so in many cases this kills the connection and keeps the bad guys out, because that's what we want with a firewall. We want to allow certain packets in and other things out. They call it packet filtering, or they used to call it packet filtering, and now we call it firewalling. And the reason we call it filtering is we're looking at a filter list and a state table. And a firewall is going to use the route table to make some decisions about basic routing. But the firewall portion of it is going to use a filter list, which is a list of characteristics of the packet that we're looking for. So we might be looking for packets from a certain person or to a certain person, IP address in this case. We might be looking for packets that are to a certain port or from a certain port, so that we can know certain things about that. And this will come down to being very detailed discussions of what kind of packets are going where, why, from who, and to whom is usually the characteristics we're looking for. There can be a lot of other things that a firewall looks for, but we're going to talk about some basic ones like that. One of the things that's required to kind of understand this is to understand what a flow is. Flows are TCP packets, because TCP is a connection-oriented protocol that gets set up ahead of time. So the firewall can track that three-way handshake that happens in a TCP connection. SYN, SYN-ACK, and an ACK, and it can keep that in its state table. When it does that, it will associate other packets with that connection, and it will know, based on that connection in its state table, hey, these are okay, or they're not. It will not allow the connection of the three-way. In some cases, it won't allow that three-way handshake to happen. So flows will be based on TCP streams. Packets, like UDP packets, will be blocked based on a filter list. And we can block flows and packets. They're very similar concepts. Packets make up flows. Yeah, it can get kind of crazy with the definitions with that. A flow is a stream of TCP packets that form a single connection. That's probably the best way to think about it. And the firewall can filter on those packets and on those flows. pfSense. Used pfSense for a number of years. It's an open source product. It offers a wide range of functionality. It's probably a step or so above the functionality you might find in a small office, home office, Wi-Fi switch, access point kind of device that offers some of that kind of stuff. It uses a web-based configuration to make it easy for us to learn and play with and get at. As you move up the scale into enterprise products, you will move away from web interfaces and anything but maybe a monitoring capability, and you'll be completely at the command line. But for learning, we found that a web-based interface makes it so that we can deal with the issues we want to deal with, primarily firewalling in this case, and not have to worry so much about typos or issues that a command line might bring to it. pfSense runs on standard Intel hardware, and it can run on really old standard Intel hardware, which is really great when you want to, go play with it. You can get a really old PC. It turns into a VM really well. We can run it as a very small VM, which is what we'll do in our practical demo. The pfSense people make and sell hardware that runs on ARM processors and several other kind of processors. And they're out there for free. The software is for free, of course. With a paid-for product, you'll pay for support, where you have questions and want to talk to developers or get official support. You can go and get a number of free support. They have a wonderful forum system that's open and free, works really well for asking questions, that kind of stuff. pfSense also offers, in addition to firewall, it will NAT, it will VPN, it routes, it can handle a number of other functions. The one thing I can say, it doesn't scale well for large installations. So by the time you get to an enterprise, kind of situation, you're going to need enterprise products, and that probably is going to mean, Cisco, Juniper, depending on the size of your institution, that might be ubiquity device, just kind of depending on where you are with that. At the end here, I've listed the link to pfSense, so if you want to go look it up and have a look at the documentation, which I highly recommend. If you have questions, oftentimes the documentation is the best place to go. The forums are, of course, there, as well as download links and more. So here we've got a diagram of the network that we're going to work with in GNS3. We may see similar versions of this if you're one of my students in a class, but what we've got is an outside client, which in our case for the GNS3 demo is actually going to be the Ubuntu host machine that hosts our GNS3. It will function as our outside client. We're going to set up 3 interior clients, and we've got an Ubuntu desktop VM that will act as those 3 clients, and we'll have 3 copies of those. So we'll have one that we set up as a web server, one that we just use as a standard desktop client, but it lives in secure net, meaning it lives as one of our corporate clients might live behind different rule sets than our corporate web server might need to be accessible from the outside world. Our desktop clients never need to be accessible from the outside world. They need to be able to get to the outside world, but our outside world client does not need to reach the desktop. So some of our firewalls will set that up. We also have a firewall object here, which will be, again, another Ubuntu desktop that we set up as an FTP server. And it, as well, one should know, FTP is not a secure protocol. It's a file transfer protocol. That's what FTP stands for. But it's not a secure protocol, meaning that the username and the password are sent in plain text. So anybody with a packet sniffer like Wireshark could find those packets and know the username and the password for the FTP server. And that's a security problem. So in order to get around that, we don't allow it access to the outside world. So our firewall will block that off. However, our desktop needs access to that FTP server. So it should be able to access the FTP server, whereas the outside world, and probably the web server, although I don't think I've ever tried that, will not have access to it. There's several really important things to remember about when we're creating rules in pfSense. Rules are applied to packets and flows as the packets arrive at pfSense. So as the packet comes into any of the interfaces, it's going to look at its rule list, it's going to apply those rules. Packets and flows are never filtered as they leave an interface. This is a feature that exists in a lot of enterprise pieces of equipment. You can filter packets as they leave. To make things easy, pfSense decided they would filter packets as they come into an interface to make it easy to understand and easy to work with. And that means when we're thinking about our firewall, we can see packets as they come in from the interface to the firewall. We can see packets as they leave the desktop and they come into the pfSense firewall. As they come into the firewall, it will filter those things. And that's an important thing to remember while we're looking at rules and rule sets is packets or filters that come to pfSense. The best mental viewpoint that you can take with this is view yourself as the firewall, and as packets are coming to you, you're going to filter them. That is the best mental viewpoint you will need to get into. All right. Basic stuff about pfSense as it starts. Once we pull this sucker out into GNS3 or we have one in real life, there's some basic configuration that will need to be done before we can get to the web-based interface. It's kind of a chicken and the egg problem. So how do I get to the web-based interface? We'll have to set some basic things up. There'll be a basic wizard that we go through to finalize those pfSense settings, and then we'll be able to get to the web-based interface and set up rules and things like that. But some basic config of our interfaces will have to be done before we can get into that web-based interface. So on to the practical demonstration. This is a very brief aside in order for anybody that wants to go play with this and make it work. This is kind of a fix-it nugget, let's call it, where when I brought pfSense in, I didn't assign it enough Ethernet interfaces. So if you were to grab it the way it is right now and pull it out, you'd say there's only one Ethernet card. How can it be a firewall? And it can't. So I'm going to give you a quick overview on how to fix that. So we're going to open up all the shapes. We're going to right-click on pfSense and say Configure Template. Now the VM itself has all the right things that it needs. So we need to go to Network, but you can see here GNS3 is only seeing one of the 4 interfaces. So we dial it up to 4 and hit OK. That'll fix our problem. So when we go to use pfSense in the future, it'll have 4 Ethernet interfaces, and we can set up multiple LANs and WAN connections and things like that. All right, so before we jumped into GNS3 and details about that, I figured I'd go over the network diagram. I've already got this all pre-set up in GNS3 so that we can kind of jump right into how do we set up rules and work our way through the web interface and that kind of stuff. If you've got GNS3, you can go through the process of setting this up. For my students, you would have these objects available to you. The little fix-it nugget just before this was designed to help you in case you wanted to play with it. It's a tricky little bugger. Sometimes the VMs don't want to come up and they don't want to play nice. It can be a pain, which is one of the reasons I preset it all up so that I could kind of show it to you and we could work through some of the issues in the web interface. So basically what I've got is an outside world client here, which is 10.105.0.1, and it's going to act like our connection from the outside world. So this would be any client outside in the wide world. If you were out there on your phone or out there on in your apartment or dorm room or whatever, this would be you out there on the internet. And Voyos is playing the part today of the internet. So that's why it says internet in parentheses there. So it's got a connection with outside world, and it also shares a connection with our pfSense firewall on ETH1, which is 10.105.20.0/24, right? So those are going to be on the same network together. pfSense doesn't use ETH monikers for its Ethernet cards. It uses EM. It runs on NetBSD, so it gets to pick its own monikers. There is no standard for this. In fact, in current versions of Debian, they've gone off to using monikers based on the Ethernet card manufacturer. So when you look at it in the lab, you may not even see that. You may see ENPS 160 or something like that. And sometimes when we use GNS3, you'll see some of that kind of stuff come up in some of our clouds because it's showing the interfaces underneath GNS3, which are the ones for our host VM. In our case, our WAN side is going to be EM0, which will be labeled WAN in our pfSense web interface, and it will have 10.105.20.1. But that's going to be our outbound WAN side, and of course our outside world client will have to come in through that, and we will be firewalling there. We also have EM1, which we will set aside as SecureNet. So you can see I've got desktop down here, which is going to act like our corporate machine, right? This is like lots and lots of your corporate drones typing away, doing work at the corporation. They're all going to be represented by desktop here, and that's the one that we'll use for that. We also have an FTP server for some testing that we'll have, and I've set up an FTP server. So we recall FTP is inherently unsecure. But since it's on the same network with desktop should be able to FTP to it. We'll eventually set up some rules to block FTP from corporate network and from outside world because FTP is insecure. We don't want to show that. Corporate network over here is kind of the halfway point, right? We're going to have our World Wide Web server on it. That's what www means. So we want the outside world to be able to get to that, but not be able to get to SecureNet. So I set it up on its own subnet, and of course it sits on EM2 and has its own subnet to do that kind of stuff. So we're going to peel that one off, and we'll have different rules, and because they're on different interfaces, they'll be very easy to set up for different rules as they go. So we'll be able to have different rules for the web server than we do for the corporate desktop and that kind of stuff. So as we jump into the web interface, this is kind of our basic network design. You'll see something very similar looking in GNS3 when we get there. All right, so the basic thing here is this is our network design. I wanted to mention and forgot to earlier that I will have a PDF of the network diagram that I will attach to this video so that you can download and look at it while we're doing this if you want to track IP addresses and things like that, because it's not going to, of course, be here, but I'll be typing away and pinging or whatever, and you'll want to know what the IP addresses are. So we'll attach that as we go. Looking at this, you should be able to see basically the same diagram, right? Outside world PC and desktop and web server and all that kind of good stuff as we go. These are all run in VirtualBox with the exception of the virtual switches. Everything else is, and you can see all the little dots down the side. I'm going to click on VirtualBox, and it's going to show me a whole bunch of different interfaces. And several of these we're never going to touch. Never going to touch FTP because I'm going to FTP to it. I know it runs. I tested it earlier. We're going to look briefly at the pfSense one, the console. Voice 1 is running, and I'm not going to really mess with it. I don't want to close it because I might need to get at it, but we'll go over briefly what we're looking at here on Voice. This is the Voice console, as you can see, and it sort of, I hit enter on it, and it's going to show me all my interfaces. I've pre-configured them. It shows up with WAN and LAN, and I had to go in and configure opt1, but you can see it shows all of its IP addresses and things like that. And you can see there's not a ton to do here, other than basically set up some basic IPs. If you panic, you can reset it to factory defaults and things like that at the console, but most of what you need to do is in the web interface, which is why I'm not super worried about being on that one. The two that we're most likely to use in our case are going to be desktop and outside world PC. So I have changed the background on both of those. So there's desktop, and here is outside world PC. So you can see I've got two different desktops on them, so that way I can tell them apart. They're of course labeled on the top, so that makes it helpful. It says desktop, says outside world, so you can tell the difference. I've pre-opened a couple of things that I think we're going to need, so that I've got them running when I want them. But the very first thing we're going to want to do is prove that everything works. I went through and set up all the interfaces and set up rules to allow everything through. And this is not the way firewalls normally work. By default, they block everything, and then you have to set up rules to allow things. And part of our lab will be going through and setting everything up so that it all works basically like a router. And it turns pfSense into a very not fancy router, because that's all it's going to do with no firewall rules, or more importantly, with firewall rules that say allow all. And in order to prove that works, we're going to test things that maybe shouldn't work. Like, do we want outside world to be able to get to the FTP server? Well, if everything is allow all, it should allow that. So if we go to outside world PC here, we're going to be able to go from outside world PC to FTP. Now, one of the things I'm going to implement is a rule that will say, no, don't allow that. We don't want the world to be able to do that. So let's go to outside world here, and I've got FTP set up. And there you go. You can see it's 172.16.1.1. And there we go. Now, you're going to say, but you didn't log in. Nope, didn't log in. Don't have to. As long as I get this kind of prompt, the TCP connection happens. The login prompt happens after about half a dozen or more packets have been transmitted back and forth between the FTP server and the FTP client. All I really need to do is get a login prompt, and that proves, yep, FTP worked. When it doesn't work, the FTP client will sort of tool around for a long time. It'll continue to send SYN packets trying to set up the three-way handshake, and pfSense will throw them away. And so it'll basically never get to this point. And all you really need to do is hit Control-C, and there you go. It kills the FTP session. You could log in as ITS class with the right password, and it would let you in, and you can tool around on the machine. We're not really here to learn about FTP, but it would let us in. The second FTP test you can run is going from desktop. So that will be from here, this desktop machine, to FTP, which should always work since it doesn't have to go through the firewall to send those packets. It's on the same LAN with it. It should work just fine all the time, no matter what rules we put into the firewall. And again, we get a login prompt, we're all good, no big deal. We hit Control-C, it drops it back to the prompt, and we're good. Desktop is also going to be what we use because we're inside the firewall, and it's the interface that we're going to use to get at the web server. And to make things a little bit bigger, I'm going to full screen the browser. That'll give me a little more screen real estate for you guys to see what's going on while I'm talking about rules and things like that. All right, so what we've got here is, we're going to go up to interfaces. We can see all our interfaces. And there we go. There's all three of our interfaces. So if we need to change IP addresses, that's where interfaces would be. We've got firewall. So you can see we've got NAT. pfSense does a lot of cool stuff. We're only interested in the firewalls at this point. So we're going to go to firewall and then to rules. And that's going to bring up the rule interface. And it's going to show all three, well, in this case, four. We won't talk about floating rules. They're kind of an advanced topic. But we've got all three interfaces. And you can see there's rules in place. Now, I've created some of these to make sure they're here. Now, remember, there is always an implied deny at the bottom of every list. Every packet that hits the firewall on an interface that's firewalled will go through this list until it matches a rule. And if it doesn't match any rule, it'll hit the bottom and it'll hit the implied deny all where it'll be thrown away. My first suggestion to everyone is to create an explicit deny all as your very last rule. And the reason for this is you normally can't log on implicit rules. And oftentimes when we're trying to diagnose what's going on, I can log on explicit rules. So if my last rule is deny all and I know it's going to catch everything else, I can log on it and figure out where it went. Because sometimes if you don't have that, it'll go through the list and it'll disappear and you'll be like, where'd the packet go? I don't know. It's not in the log anywhere. How can it be in the log anywhere? It got blocked. No explicit deny all, no logging. That could be a problem. You can see here, before the deny all, I set up an allow all, which is what this says. You know, stars means everything, so it's letting everything in. I was a poor firewall administrator, did not put a description in, so I can hit the little pencil over here, which is our edit, and it will bring up the rule for me so we can look at it. And this will give you a good time to look at sort of the overview of what a rule looks like. This is my allow all rule, so I'm allowing it to pass. You know, I can pull it down and I can pick block and reject. Reject sends back a message to the client saying, hey, I threw your stuff away. Sometimes we don't want to do that. We want to be super sneaky and paranoid with our tinfoil hat. We can move the interface that it's on, which is kind of nice. We can disable the rule, which is nice because that means the rule's still there and it's just sort of a binary on-off switch to turn it on and off when I want to use it. I can pick the address family. Remember, if you're only using v4, you can get away with just v4. But if you implement v6 and forget to do your firewall, it can get real exciting because all of a sudden, if all your rules for v4, there'll be a deny all on everything that'll catch all the v6 packets and throw them away. But you may get into some trouble of why doesn't this work, or it should work, or it might work, and it can be very frustrating. Protocol gets interesting. We have TCP, we have UDP, we have TCP or UDP, and you can see we have a ton of other packets in here that go down the list. Let me scroll down just a little bit. I couldn't even get the whole list on there. And you can see there's a ton of them in there. V6. The ones we tend to use are these top four. ICMP might get if you wanted to block ping. The rest of them tend to be a little more specific for what we want to do. In our case, we're doing an any rule, so we want protocol any. Again, we're going to do source matching of any, but we could just as easily pick a single host or a network. And we'll build another rule here in a little bit to block FTP from outside world client. We'll talk a little more about how to do that. We'll have destination any, so we can block either a source or a destination, or we can filter on source or destination. Down here at the bottom, you can see we've got logging. And we talked a little earlier about logging. If you want to log the packet, you can click on it. There's even a link to the logging page. Takes you right there if you want to log on it. And a description setting, which I did not put in. So we'll type allow all. And it can be any text string you want. There's a save button at the bottom. And it will save your changes but will not implement them. And that's so you can make multiple rules that might be, contradictory if you need to be as you're going along, and then apply them all at once. So it'll pull out certain rules and add other rules in there. And that might be very useful as you go along through this kind of phase of testing. So we'll hit apply, and it'll apply all my rules. In this case, it really didn't change all the rules, but it does take a little bit once we apply. And we can see the browsers down here chewing away. More rules you put into place or have into place, the longer it'll take for it to grind through. Other things to note, the order of the rules matter, because packets are going to go through the list from the top to the bottom, and when they find a rule, they're going to follow it and shoot out. So the order of the rules matters, and that means I can grab rules and change orders if I want. And now I'm denying everything. Nothing will ever get to the allow all in this order. And I can put it back. I can add new rules, and if I wanted to add them in a certain place, I could check the little box in the rule and say add above the checkbox or add below the checkbox. And I can, of course, save and do things. I can add visual separators. I can delete rules. The little pencil is to edit a rule. We can move checked rules above this one, so we can anchor it in place and move it around. That's for reordering rules. We can duplicate a rule. I could kind of rule the way I like it, and I want to do one very similar. I can say, yeah, just copy this one and let me play with it. This is the enable disable. So we saw the checkbox when we were in the rule. This is a fast way to enable and disable rules. Nice, easy way to play with it to make sure, is that the rule that's causing the problem? And of course, the trash can is to delete the rules. So we'll hit save. I think reordering it screws with its head and thinks that it needs to be reordered or saved, or it'll get upset. pfSense gets upset very easily, I've noticed. And we can go to LAN. LAN comes straight out of the box with a couple of pre-made rules, because of course your LAN clients are supposed to be able to get out. WAN blocks everything right out of the box, and that's I reconfigured ours, so it's not quite that way. But these are the standard rules that come right out of the box with pfSense for the LAN side. And our top rule here is an anti-lockout rule, and this allows port 80 to get to the LAN address of pfSense. Otherwise, we'd never be able to get to the web interface. It's to keep us from locking ourselves out. And it's always the first rule on the LAN side, because otherwise, if you move it down, you could cut off your nose to spite your face. So they make it the first rule. And that way, if you're ever going to the pfSense box on port 80, you'll get there, assuming you're coming from the LAN side. You can also see default rules that allow it. Now remember, from pfSense standpoint, these are packets coming to pfSense from our secure net. That would be LAN as our secure net. Those are the two things. So it's going to allow them through, because we want outbound traffic to be able to leave. It's got to be able to get into pfSense to be able to then get out. So these will be outbound rules. The default settings are very similar to a home router that you might buy and stick in front of your cable modem or your DSL or whoever your ISP is at home, right? It'll block everybody from getting in, but it'll allow all the clients on the inside of your home or your small business out through that. And it emulates that kind of right out of the box. Our Opt1 interface is the third leg of our three-legged dog, and it comes with no rules at all, other than the implied deny all. So when I set it up originally, our web server box couldn't go anywhere. I couldn't talk to the web interface. I couldn't talk to anybody because the implied denial cut me off. So I had to be on a machine in the LAN interface to be able to get at it to set up rules, which is why we use desktop to get at it and create the rules, because originally I couldn't get there from the web server. With these rules that I've created, I can. And you can see I've created an allow all and a deny all, so that way we can run some tests. So one other test we can run when we look at this, we should be able to get from outside world and from desktop to web server. Web server is just running an Apache web server. It'll give us the standard Apache web server page. And if we go to outside world PC, we can type in our address. Okay, and web server's IP address is 172.16.2.1. And it'll load the basic default Apache page. There's one problem that comes with this. Now that the browser has that in its cache, it will always show us that page. Now there's a couple of ways to get rid of it, right? You can go clear your browser cache by going to history and saying clear recent history, and that will blow it all away. You can say last hour or forever or whatever, and it'll clear it all out. And you'll be able to go, which means it'll go re-download that every time you hit it. So when we finally put a rule in place that blocks access from outside world or from desktop or whatever we want, we will have trouble testing it if we don't first clear the cache. The other way you can do it is if you hold down the control key while you refresh the page. As long as you're holding the control key down, it won't use local cache for anything. The minute you take your finger off the control key, it'll instantly go to the cache and populate it. So by doing that, I've got the control key held down. I could also hold the control key down and hit the little button here, and it'll reload the page. And you can see it force reloads the whole page. Rather than this, which doesn't do that, right? I had the control key off for the second one. So there's some little tricks that go with that. It's worth knowing as we go along through this. So now that we've got everything kind of proven that it works, we need to go implement some actual security, because basically what we did was imply no security, and that's not really what we want. So let's go and turn back on all the security that we had by going to things, and we're just going to disable the allow all rule, which is good, right? We generally want the we want that turned off, generally speaking. And this is, remember, these are links from web server going out and LAN going out. So the allow all there is okay. The one that we really want to block is the WAN. We don't want to allow everything in. So I just went and disabled that rule, and pretty much everything coming inbound is going to stop. It's going to turn into a one-way door that will only work going outbound. We'll be able to get to places out, but nothing will be able to get in. So if we go and do stuff like this, where we try to get to FTP server, it will pretty much die, which is what we want it to have happen. We don't want things to be able to get in. You can see it's basically in a timeout phase, and it'll eventually drop to an FTP prompt and say, I can't get there. And we can type exit and get out. So this is the behavior we're expecting. We don't want the outside world to be able to get to that. But it's funny with, I'm gonna hold the control key down here and refresh the page, and it's gonna, whoops, control key, shift key. Wow, I totally gave bad advice. I'm going to hold the shift key down, and it's going to sit and spin and spin and spin, and eventually the page will time out. And of course, the other way to do it is just go, delete the cache. We try that too. right? Go and delete the cache. Delete everything from the last hour. I haven't done anything in the last hour. 2. Dot 16 dot 2 dot 1 will pretty much just sit and spin forever because the WAN side is blocking everything. But we really want the outside world to be able to get to our web server. So maybe we should write a rule that allows for that. So we're going to check the little box because we want a rule that's above the allow all in case we decide to use the allow all later. And we'll add a rule. And this will create a rule and stick it at the top. We want it to pass. We don't want it to be disabled at the moment. On the WAN is what we want. IPv4 is what we want. TCP is what we want. Source is anywhere. That's great. That's what we want. And down here we want to say destination. So in our secure net, we might have a variety of different services available to us. So we may want to write a very specific rule that only allows access to one machine at a very specific port. Because we might have other things in there to pick and choose and look at. So in this case, I said only port 80 on our web server, right? Web server is 172.16.2.1, and I'm only allowing port 80 access to it. And it's even still spinning here in the background. So we'll hit stop so that it stops spinning. And the minute I apply this, it'll jump right through, and our web browser may very well grab that. Oh, I was a bad person. I didn't end a description again. I know, it's terrible. I'm sure my mother will chastise me. And ta-da, look at that. All of a sudden it works. So we write a rule that it's an exception to the firewall. And when we say exception, we mean exception to the default deny all. And you can see it picked up one connection, and it had 9 kilobytes of data passed. That's kind of the basics of how you create rules. We just keep stacking them on top of the deny all for different services and different needs. So if I want to deny the web server access to the FTP server, so I could go to the FTP server, go to the web server's console and try to get to the FTP server, we can write a rule that does that. And we'd have to write it on opt1, right? In our network diagram, that's where we're firewalling. Right now we're allowing all. So again, we will add a rule above the allow all, because most of the time we want to let stuff out. It's usually the stuff letting it in that we're worried about. In our case, we want to keep, if anybody breaks into our web server, we don't want them to be able to hopscotch into our FTP server. So you can see I've got the rule blocking. I think it's blocking. I should go look. Nope, I want to say block. We're on opt1, we're IPv4, we're TCP. And what's our source? Well, our source is anybody that's on this network, so we can say any. And our destination is going to be the network that is secure net. So we're going to block all FTP connections, just in case somebody else goes along. If desktop somehow sets up an FTP server, that would be, bad. So we'll say 1.0/24. There we go. And we're going to specifically pick FTP, port 21. So this will block that when we apply it. And before I do that, I will go show you that it does work before I apply it. So we can see the rules are here. And if I pull up the desktop to web server, and I open a terminal, I can do an FTP to 172.16.1.2, and my FTP client works. And once I hit apply on this rule, it'll block it all. So we'll hit apply changes, and we can test it by going back and doing this, and it blocks it. And it'll, of course, the FTP client will eventually time out. So I'm just going to Control C. All right, so those are some basics of how to create rules, where they apply, how they apply. If there's more questions, I may come back and add to this video a little bit. I hope this is enough to kind of get you started with pfSense and creating rules. Remember, it's really important to remember that pfSense only filters on packets as they come into an interface. So you have to keep your mental mindset of I'm the firewall and packets are coming in the interfaces. So we never filter packets as they go away from an interface, only as packets come to an interface. Hope you enjoyed this Tech Nugget. We'll do some more in the future.